Hello everybody, welcome back to CIS 17A. We are now at lesson number 16, classes part 2, getting very close to wrapping everything up here at the end of the semester. Alright, so lesson 16, we're going to continue talking about classes. This is the following pages from the book, 728 through 757. Alright, now before I get into the new parts of today, I do want to do a quick recap on what we did last time. All right, so we talked about the difference between procedural programming versus object-oriented programming. So in procedural programming, which is what we've been doing, we mainly rely on the main function. We declare all our variables inside of main, and then when we want to interact with those variables, we could potentially write functions outside of main. We put our prototypes up here, our definitions down there, and we call those functions inside of main to solve our problem. One of the things we noted is that as programs become large, that's not a very practical way to approach solving a complex programming problem. Thus, object-oriented programming and C++. So in C++, we favor working with objects over functions. So to declare a class, we use the keyword class followed by the name of the class. Whoops, reckless. Do that. We put the keyword class followed by the name of the class, and I mentioned that sorry, and I mentioned that you usually want the first thing, the first letter of the class to be capitalized. Next, you're going to put the curly braces that defines the body of your class, and you don't want to forget to put the semicolon after that last curly brace when it's a class. Next, you're going to have the keywords private and public. And this specifies what is protected or what the user is not allowed to directly access versus things that the user is or allowed to directly access. And that's going to usually take the form of variables, which are called attributes, and functions, which modify or retrieve those attributes, called member functions or methods. All right, so that's how we can define a class. We also mentioned that if the member function is not going to modify something, in other words, it's not going to change the value of the length or width, then we should make it a constant function so to prevent it from accidentally changing those values. All right, next, we talked about how we can define all of these different functions, and we do that by using the scope resolution operator, the 2 colons, and we have to put the name of the class before we put the name of the member function or method. So these are all really simple functions where we're just passing a parameter to it, and then we're using that value to initialize the data or the attributes of the class. We talked about the difference between a class and an object. So we said that a class is like a blueprint, and it's something that's arbitrary, and an object or an instance of a class is more specific. So in this case, we're saying that the rectangle is a box, but a rectangle could be anything. It could be the square footage of a house. It could be the square footage of one part of the house, like the kitchen, right? There's many different ways of many different forms of a rectangle. All right. Next, we said that there are 2 different ways we can use objects. We can either use them as pointers, or we can use them as just a regular instance of the object. So let's start with pointers, which is what we ended with. So if we do that, we use the star to indicate that this is a pointer to a rectangle, and then we use the keyword new along with the name of the class, rect, in order to dynamically allocate a new rectangle object and assign the memory address of that object to boxptr. Next, we did a couple of things to initialize it. We asked the user for the length, and then here was the next new thing, is we called the setLength member function. In this case, we use the arrow operator because it is a pointer. If it was not a pointer, we would use the dot operator. And then we're just taking whatever the user provided and then passing that so that we can initialize that to the length value. All right. So we did that for the length, we did that again for the width, and then we just had a simple function down here which printed out the area, which is the length times the width of the box, by calling the getArea member function that we defined up here. And all that does is return an integer, which is the length times the width. Okay, and then last but not least, we said that if we do dynamically allocate something, we need to always call delete on the dynamically allocated object before we exit the program. And if we don't, that's something referred to as a memory leak, and memory leaks are bad. Sorry, I have a scratchy throat today, guys. You're going to hear me clearing my throat a lot. It's the allergy season. All right, anyways, so yeah, so that's a summary. Now, we just to show you, if we didn't want to use pointers, all we would do is this. We would go in here and then just make that a regular instance to it. And then down here, we would not use the arrow operator. We would use the dot operator for everything to call. Like this. And then because it's not dynamically allocated, we no longer need to delete it. Okay, so that's the other way that you can declare an instance of a rectangle class, an object. In this case, we called it boxPTR. Okay, so that was not everything, but I just wanted to go ahead and do a quick review before we talked about the new stuff for today. All right, so the new stuff for today starts off with section 13.4, why have private data members? Now, instead of reading through this, I'm going to go ahead and skip this a little bit because I already talked about this actually in the last class. So the reason we have private data is so that when we are initializing an instance of the class, that we can do a little bit of error checking. So for example, this is the function, let me make this bigger. So this is the function set width that we defined, and instead of just directly setting width to w, that's this variable here, we can do error checking like, is the person providing us a value that is greater than or equal to 0, then it's a good number. We can assign it. Otherwise, we have to do something else like print out to them, hey, this is not a valid width, and then do something else. Now in this case, it's choosing to call the exit function, which causes the program to terminate. That's pretty extreme. There are more graceful ways of doing error checking, but that's probably something you'll cover in a more advanced programming class. So you can use something called exception throwing to more gracefully handle something that's bad. So that's why we want to have private data, so that we can do a little bit of error checking before the person modifies the attributes of the class. All right, let's see. Separating the class specification from the implementation. So typically when we do classes, we don't do it like this. We don't put everything inside of your main.cpp file. We split everything up into separate files. And as it mentioned, one is called the specification file. That's also referred to as the header file. And then there's the implementation file, which gets its own CPP file, just like main.cpp does. All right. Typically, the class specification file is going to be what contains the class declaration. So everything that we put from here to here is the class declaration, and that would all end up in the specification file or the .h file. All right, and we typically put the name of the class as the name of the file. So when we create the header file, we would call it rectangle.h. Okay. In the implementation file, that's typically the .cpp extension, and that's where we place all the class, all the member function definitions for the class. In other words, and we call that by the name of the class as well. So you're going to have a rectangle.h file and a rectangle.cpp file. So all of the member, where are we at? All the member functions from here to here, where we defined all of these, those would all be in the implementation file or .cpp file. All right. And then of course you're going to have your main.cpp file as well, which is going to have to use a sharp include statement that includes the header file for your class. All right, so I'm going to go ahead and just do that. And because I know some of you are using the online compiler, I'm going to demonstrate it in here. And then if you're not using the online one, I'm assuming again that you're using some type of compiler that you're familiar with and that you know how to split the files up. All right, so how do we add a new file here? Let's start off with the header file. Okay, and I've already included rectangle.h, so let's go ahead and create the .h file. So I'm going to go to new and call this by the name of my class, which was rect, short for rectangle, and this is going to be a .h file. Okay, so there's my rect.h, and then just to show you, in the interest of time, it is everything from here to here that would go, I'm going to go ahead and just copy it, that would go into that file. All right. Next, we would need to include, so this is the specification file. Next, we need to include the implementation file or .cpp file. Again, you give it the same name as the class, and that's where all of our function definitions would go. So that's where all of this would go. Okay, so all of our function definitions. So again, I'm just going to copy and paste that code into here. Also remember that you need to, in your implementation file, include the header file. And we don't do it using the angle braces. We do it using double quotes like this, rect.h. Now the reason is, without getting into too long of an explanation, is that when you use the angle braces, like sharp include with these two guys after, those tell the compiler to go look into a folder that is located on your computer that has all those header files in it. So you may not know that whenever you buy a computer, it actually has a folder somewhere on it that has all of the header files used in C++. Even if you're never going to use that computer to program, that folder does exist on every computer that includes a commercial operating system like Windows or Mac OS or Linux. All right, so what it's doing is it's saying, instead of looking in that default folder by putting the double quotes, it's saying that this file is going to be located in the same file as main. All right, so that's what that's for. All right, so note that you need to do that for the implementation file, but obviously we do not need to do it for this file. And what's really happening behind the scenes is it's doing a copy and paste. When you say sharp include rect.h, it's going to copy this code and paste it in place of this. And that's what's really happening behind the scenes. Okay, now since main is also going to be using this rectangle to declare instances of a rectangle, I actually spelled it different last time I did it, so we would need to also include it here in main. Okay, so let's see if that's enough to let us declare an instance of a rectangle called box. Okay, so let's go ahead, and if I run this, it's not going to do anything. It's just going to go through. And yeah, so it didn't do anything. All it did is declare that instance of the box and then end. Okay, so moving forward, when you guys are writing classes, which is what our focus is going to be on from now on, this is the basic way you can do it to split up your classes. And if you have more than one class, you just do the same thing over and over and over. So if I was going to maybe have a class called circle, I'd have circle.h, circle.cpp, class declaration would go into .h, class number function definitions would go into the .cpp file. Same thing in circle.cpp, you need to include circle.h, and over in main, you need to also include circle.h to use or to declare instances of it. All right, now there's one last thing to mention, and I'm going to go ahead and switch over to the book for a second. Okay, and it's these guys right here. Okay, so it's possible when you are writing a program to accidentally try to include something more than once, and that's not allowed. So I can't include anywhere in my code, I can't have a repeat of this class declaration for rectangle. If this was accidentally included in more than one spot, I would get a compiler error. All right, so what you can do is you can add what are called include guards. And include guards make sure that that never accidentally happens. So anytime you write a .h file, you should always put these include guards in here, and that also needs to use that as well. And really what this does is the following. This is a preprocessor directive, so this happens before the code is actually compiled. It's the stage, remember the preprocessor sets up the code so that it will have a fair chance at compiling. And what this means is if ndef, or if not defined, and it's looking for this word rectangle underscore h. Now the way that that word gets defined is by using another preprocessor director called define. So what this is really doing is it's looking to see if this line of code has executed anywhere prior to when it's checking. And if it has, then it knows that the class declaration has already been included and doesn't need to be. So again, in English, this would read as if not defined rectangle underscore h. It's not defined, so I'm going to immediately define it. And then I'm going to go ahead and put my class declaration, and then I'm done. End if. And that's going to end off this if statement right here. All right, so you always want to include that in your .h files to make sure you don't get that compiler error message that says multiple inclusions is what it will say if you don't. So let's do that. So sharp if not defined, and then you're usually put in all capital letters underscore h, use the name of your class. Oops, my computer's getting a little laggy. Okay, so put the name of the class in all capital letters underscore h. So if it's not defined, it hasn't been included yet, so we immediately want to define it. So sharp define, and then put the exact same name underscore h, like so. So next, we include the declaration, and then we are done. So we say end if. And there you go. That's an include guard. So you should always put that in your .h files. All right, so I'm going to go ahead and skip running this, so you can trust me that those guards will work to prevent this from being included multiple times in your code. Okay, let's move on here. So here it's just talking about the include guards. And then this is explaining the same thing that I just explained a moment ago. Okay, and then here they're going to go ahead and get a little bit fancier. So now in the book, what they're assuming is that these files are now going to be split up. Not everything is going to be sitting all in one file in main. And they're just going through and showing you basically the example that I just did, but they're also going to go ahead and revise their set functions to do some error checking to see that the user provided a valid thing. The rest of the functions all do the same thing. Okay, let's see. Okay, so here they are just explaining what I just explained a second ago. They're just explaining the difference between using the angle brackets versus using the quotes, and how it's going to basically copy and paste the declaration that is contained within the .h file over into the .cpp file for it. Okay, and then here they're just talking about how any file that is going to use a member of that class needs to make sure to include it. Otherwise, it won't recognize this over in the CPP file. So when you say RECT, that's not been declared anywhere. So that's why it's getting it from the .h file. That's all they're explaining in the book. All right. And then here they're just summarizing what actually happens behind the scenes during the linking stage. So what happens, the picture down here is better than reading through all that stuff up here. So this is what actually happens when you go to compile a program and you have it split up into multiple files. So in your main.cpp, you include rectangle.h. In your rectangle.cpp file, you included rectangle.h. So what happens is at this stage of compiling, it uses that information to properly compile all the code. And then because you now have two separate pieces of the code that exist outside of the same file, it creates a temporary file called an object file. And then that's what contains the actual runnable code. And then during the linking stage of compiling, it takes all the different object files that are created and it links them all together to finally create the executable version of the program that you can run. And we never see the .exe. It's there, it's generated behind the scenes, but we never actually directly implement that exe file. What you could do is if you browsed around and you found it, you could double click on it and it would open up the console and run the program. All right, but we always get that for free because we're using a compiler. Okay, moving on. Inline member functions. Okay. When the body of the member function is written inside the declaration, it is considered to be an inline function. And quite simply, it looks like this. So normally we would put under the public section of the class declaration all of our prototypes for our member functions. So remember, a prototype doesn't need to have a name for the variable, it just has to have all the types in the parameter list, and then that's it. Versus a function definition, which has the parameter, the header, and then after the header we put the curly braces and we put the body of the function, right? Now, when you do that all as it said right here in the class declaration, that's an inline function, all right? So why use inline functions? Well, there's a couple reasons you might want to use them. One is that behind the scenes, and it gets into a pretty lengthy discussion about this down here on inline functions and performance. Behind the scenes, what happens is every time you call a every time you call a member function, there's a lot of stuff that happens behind the scenes on your CPU in order to make that function call. When you inline a function, what it does is it just places that line of code right there in the place where you normally would be calling the function. And what it can do is it can speed up or improve the performance of your class. Now, it is worth also mentioning that when you make a function inline like this, that it's not a guarantee that the compiler will actually make that function inline. So for example, if I try to hit an inline function here and it's very, very long and I have 20 lines of code, the compiler will probably reject my suggestion to make it inline, and it won't cause a problem. It won't fail to compile or run, but behind the scenes, it's actually going to do regular function calls and not make it inline. So you should know that for a quiz and exam, that just because you make a function, a member function inline, it's not guaranteed to actually be inlined when the program's compiled. Okay. So down here they are inlining, or actually they're not inlining everything because set width is pretty long. They're just inlining these simple functions here. All this is doing is one line of code, returning the value of the width, returning the value of the length, and then returning the length times the width to get the area. All right, so that is an inline function. Now the other thing worth mentioning is that if you use inline a lot, it can actually cause the size of your program to increase to be larger than it would be otherwise. And again, this is something that the compiler actually looks at on its own. And if it sees that that's happening, that you've inlined too much and it's bloating the code, it'll just not make the functions inline. It will treat them like you define them outside of it. Okay, now there's, and then also briefly worth mentioning is that this book is kind of old, and compilers have gotten really good over the last 20 years that C++ has been around. And compilers these days are usually really, really good at the way that they make things inline versus not inline. And so there's not a big reason to do this. If you're really trying to improve the performance of your program, this is probably not going to really help that much. All right, so it's more useful for me as a teacher because then I can just kind of, to illustrate examples of things, I can just quickly demonstrate like I'm going to do right now. All right, so let's see. So what I could have done is simplified things by just getting rid of these and then just gone up here and said inline that the width is equal to, and then over here, int, oh, not width, length, so L, so the length is equal to L, semicolon. And that's it, that's an inline function. And you can see why they call it inline, because it's all in one line, okay? I can do the same thing here, W, width is equal to W. Now again, the thing that's not really great about this is it's not doing any error checking, right? So the person may provide garbage values. Oops, need to put a semicolon there. So the person could provide garbage values when they call these functions, and it's not going to check it. So anyways, just want to demonstrate quickly how you can create an inline function. Okay, so let's skip down here to constructors. So usually when you create an object, you want to try to initialize it at the moment that it's created. Now you can't always do that, but you should do it as quickly as you can when you create the instance of the object. All right, the constructor is called whenever it's a special function. So a constructor is a special function, as you see down here. So here's a new class called demo. And the name of the constructor is always going to be the name of the class. Notice a couple things about this. Number one is that it doesn't have a return type. And that's an important thing to know about constructors, is constructors do not return values ever. So you never have a void or int or anything over here on the left side. It's always just going to be the name of the class that's used, and that's how the compiler knows this is going to be the constructor for the class. Okay, down here, here's the definition, and kind of funny, you're going to put the name of the class like you normally would, but in this case, since it's a constructor, we put the name again. So you're always going to see that with constructors, is that they have the name twice. Now, you would never explicitly call the constructor for a class. The constructor is called automatically when the instance of that object is created. So let's go ahead and go back over to here, and let's add a constructor to our rectangle class. The constructor should always be public. All right. So we're going to call it RECT. And in this case, we'll just make it do nothing. All right. And then we got to add the definition for that. So again, a constructor doesn't return anything, so we don't put a return type. Still use the scope resolution operators, followed by the name of the constructor. I can't spell. And then in this case, we're saying that it doesn't get passed any parameters. And that's another thing worth noting, is that you can pass arguments or parameters to a constructor. And we'll see that that's very useful to do that when we initialize the members of the class. Okay, why am I getting a red squiggly line here? Oh, demo. Rect. Sorry about that, you guys. Okay, there we go. All right, no more squiggly lines. All right, so that's our constructor. And then just to see the constructor actually work, let's go ahead and put a quick cout statement in here. In the constructor /n. All right, so that's all our constructor is going to do, is tell us that it actually ran. All right, let's go back to where we actually declared an instance of it. So here we're not declaring a pointer, we're declaring an instance. So when I run this, we should see it print first in the constructor. Okay, so notice that I didn't call that function to get that to happen. I didn't call RECT. That happened when I declared the instance of the class. So notice that's the first thing that it prints. And then it prints enter the length, which is the next cout statement that appears here. So 4, and then 5, and then same thing, it's just printing out the area. All right, so that's how a constructor works. It's worth noting that when you use pointers, let's do it this way. And then we're going to go ahead and modify these to use the arrow operator instead. Then we have to delete it. All right. So now something interesting is going to happen here. If I were to just run this as is, let me go ahead and comment out all this code here. Okay. So all I did is comment out this code so that it won't run. So to the compiler, the program looks like this. So let's go ahead and run it and see what happens. So we know that it calls the constructor when the object is created, unless it is a pointer. Because remember, right now, it's not creating an instance of the class, it's just creating a placeholder for the memory address of the instance of that class. So the constructor, if it's a regular object like this, it will call the constructor. If it's a pointer, it's going to wait for you to assign the address of something to this. Well, that's not true, because there's two ways we could do it, right? We could do two different ways. We could create it right away by doing this, new RECT, okay, and right away it's going to create a new instance of that box. So in this case, as soon as we call new, it's going to call the constructor when it initializes this instance and then assigns the memory address of it to here, okay? Or we would have had a different non-pointer version up here that we would point to, in which case it would be called, the constructor would be called at that point. So box, and that would have to be capital R, like this. Okay, so if we were to run it, and then assign it the address of box and box. Okay, so now in this case, it will call the constructor, but it will call it here. It's not calling the constructor here, okay? But this will correctly initialize box PTR. All right, so let me go ahead and delete that. And then just so you can see the difference, let's go ahead and call new RECT. and run it. Come on, run. Why aren't you running? Oh, because there's another console already open. Okay, let's try that again. Run. All right, and this time, ta-da, it says in the constructor. And it says in the constructor because I'm calling new. And then again, just to show you that, if I don't put new, if I just declare a pointer to a rectangle and I run it again, it will not call the constructor. It does not say in the constructor, okay? So make sure you understand the distinction there. Okay, so that's what a constructor is. What else do we need to know about constructors? So here it's just showing you the same demo that I did, showing you when it's calling the constructor. Okay, here it's mentioning that the constructor doesn't return any values. It doesn't even return void. It doesn't return anything. Okay. So here what they're trying to say is that that it's important that when you create an instance of a class, I should highlight that instead. It's important when you create an instance of a class that the attributes in the class get initialized to something. Because remember, if you don't assign some value to them, they're just garbage. So in a case like this program here, let's check the set width. In a case like this program here, what they're doing is saying that the constructor is going to at least provide a value of 0 to everything when the program starts up. So the problem is that, let's go back over here. Okay, let's bring this back. The problem is that if you don't initialize the attributes to something, if you just leave them as garbage, it's possible for a person to do something like this. So I have not initialized anything. I'm going to comment these things out like so. So this is what the program looks like at this point. Let's go ahead and just give it something equal to a new rectangle. Okay. All right. So this is a totally valid program in terms of there's no compiler errors. But notice that I didn't initialize the height, the length and the width to anything. I just created a new instance of the object. So when I call get area, let's go ahead and run it and see what we get. It's just going to be some random number. Negative whatever that is, right? So obviously this is just some garbage number. So this is not good. So this is one of the reasons why we want to use constructors. So we could do something like the book shows here, where we at least, when we create the object, use this. This is something called a default constructor, by the way, which I'll talk more about in a second, that we at least provide the value of 0, 0. So if we do something like that, besides saying, hey, look, we're in the constructor, we can say length is equal to 0, and width is equal to 0. So that if we do come back and do something like, this, where we call it before it's been initialized, we don't get some strange arbitrary number. We get 0 times 0, which is, the area of the box is 0. So at least we get something that's not crazy, right? Okay, let's get back over to here. Okay, so next the book just continues to run through this example using the revised code. This is the same code you've been looking at over and over and over. Here's the main, where again we just create a box and then print out the height, width, and area. And it's showing you this time, since we didn't provide anything, here's the default constructor initializing everything to 0 for us. Okay, the next thing the book talks about is something called a default constructor. Now, quite simply, all you got to remember is that a default constructor takes no arguments. So in all the examples we've seen so far, it's always been the case that the constructor had an empty parameter list where we're not passing any values into it. So if that is the case, if we do not pass the constructor any arguments, that is called a default constructor. Now the other thing to know about classes is that if you write no constructor whatsoever, the compiler will still automatically generate a constructor that looks like this. So if you do not provide any constructor whatsoever, you will, behind the scenes, actually have a constructor that looks like this, which is passed nothing, which does nothing, and which returns nothing because it's a constructor. All right, so this is yet another example of a default constructor. However, this is a default constructor that is automatically generated because you didn't provide anything for the class. And you should always provide a constructor for your class. All right, so again, just keeping it simple. A default constructor is a constructor that takes no arguments. If you provide no constructor whatsoever, you get one automatically. Okay, here it's just mentioning what I already showed you guys, is that the default constructor, I don't know why they're saying this for default, specifically for default constructors and dynamically allocated objects, because what it's saying here is true for not just default constructors, but for any constructors, is that the constructor doesn't actually get called until you say new if you're using pointers, but I already demonstrated that. All right, passing arguments to constructors is very similar to the way we would pass arguments to function calls. All right, and it's worth mentioning that a constructor can have parameters or objects that are passed to the constructor when you call it. So what does that look like? Just like with functions. So this is a class called rectangle. And this time in the prototype for the constructor, we're saying that it passes it 2 doubles. So note that this is not a default constructor because it has arguments or it has a parameter list. If it was empty, it would be a default constructor. All right, so in this case, we are providing a constructor with 2 arguments. And now the difference is that in our constructor, we're going to have to declare a couple of variables which have names that are slightly different than the attributes, width and length. Remember, those are your private data members. And so now when we create an instance of an object, the big difference is going to be down here in main. Get past all this, which is this right here. So now we are going to, in this example, say that our rectangles represent the width of a house and the length of a house. Again, we're just asking the user for what those values are before we create the instance of the class. I'm sorry, the instance of the, well, instance of the class is the object, same thing. So now we're going to say we are making a rectangle named house. And now the big difference is that we have to pass it values before it will initialize the class. So we can see it's just going to say, how wide is your house? How long is your house? They're going to call the get functions to print out these values right here. So notice it's using the dot operator, just like we saw with vectors and any other class. And that's the name of the member function. And then we're going to call the get area to get the area of the house. All right, so it turns out it's that big. Okay, all right, so now here's the other thing that's important. Okay, before I get into that, here's the other thing that's important. Let's go back over to here. And let's bring this back in. And let's go back up here to our constructor, and let's make this now not a default constructor, but a regular constructor. So we're going to pass in, we'll just use integers, int. So now I got to go down here and say int L, int W. And now I can say that the length is equal to L and the width is equal to W. And again, I could put some error checking stuff in here too, but we'll just keep things simple. All right, now down here in main, this is where you're going to notice something new. Ta-da! See the red squiggly lines right there? So because I said in my constructor that it takes 2 arguments, and down here I'm not providing any arguments, this is an error, right? So I have to come back here and do this. I'm going to cut it from here. Wait till I have the length. Actually, I can get rid of this. So I'm going to wait till I have the length and the width. And instead of calling the set functions, now I don't have to do that. Now I can just call, or not call, but create a new instance of a rectangle and pass it those values, like so. No, not capital, comma, width. All right, so From the outside, this program is going to execute exactly the same as it did a moment before. The only thing that's changed is that now what I'm basically saying is that you cannot create an instance of a rectangle unless you also provide a length and a width. All right, and then we'll see that it's going to print out the area like it's been doing. So let's run it. Okay, the length is 5 by 2. The area of the box is 10. So you can see there's a way, an example of using the constructor with arguments to prevent the user from creating an instance that has garbage for the length and the width. Okay. All right. Let's see here. So I'm going to go ahead and skip this example. I encourage you guys to read through it because it's doing what we just did. It's creating a constructor. So this is a class called sale. Here's your constructor, sale, and it's requiring that you pass in 2 values in order for it to be used. But again, I'm going to let you guys read through that in the interest of time. Okay, here's another example using the sale class that we just saw a second ago. So you can see here it's saying I'm going to declare an instance of a sale called item sale, and it's requiring you to pass in 2 values. All right. So again, look through that yourself and see, make sure you understand what's going on there. All right. Just as you can use default arguments in regular functions, you can also use default arguments in constructors. So recall that a default argument is when we place the assignment operator just to the right of the name of the variable, and then we put a value here that is used to initialize that in the case that the user doesn't provide that value. Now the rule for default arguments with default, I'm sorry, let me back up. The rule for default arguments is the same as the rule for when default arguments are used in regular functions. They always need to be placed to the right of anything that is not a default argument. So again, you can't say double cost is equal to 1, comma, double rate, and then not have that be a default argument. Remember, all default arguments must be placed to the right of anything that is not a default argument, whether it's a constructor or a regular function. Okay, so in this case, we are allowing the choice to the user of either specifying what the rate is or not specifying what the rate is. So let's go ahead and just jump down here and look just to see how it's being used. So in this case, the person is providing the cost, but they're not providing the rate. And I'm assuming that they have an example they don't. Okay. So I'm surprised. So here they're just letting it use the default value of 0.5. And then, but again, you could come in here and provide something. So let's just do a quick example. It's not hard to modify this stuff to do this. All right, so let's say that we were going to make W a default value of 0. Okay. All right, and then notice that you don't have to put that in the prototype. You put that down here in the definition. So now the person can have some flexibility. Oh wait. Yeah. That's all you have to do is that. So then let's go down here, and then this time let's go ahead and call it, but not pass in the width. Okay, so the area should now be 0 because it's going to be 0 times the length. So let's run it. Okay, what is the length? 5. The area of the box is 0. So you can see that was using the default value that we placed up here in the parameter list for the constructor. So that's a default argument with the constructor. Or if the person had specified, this is what I was looking for in the book and I was surprised it wasn't there. Or if they do provide the value, comma, width. So now we are going to use both the length and the width provided. Let's run this one. What is the length? 5. What is the width? 3. The area is 15. So you can see in one we omitted the width, and one we included the width and the length. And when we didn't put the width in there, it used the default argument up here. All right, so that's default arguments with constructors. Okay. So this is a subtlety of using default arguments with constructors. if a constructor has default arguments for all of its parameters, it can be called with no explicit arguments. In other words, I can create an instance of that class and not pass it anything. If it is the case that the constructor has default arguments for all, and should be in bold, all of its parameters, it's treated as a default constructor. All right. Now the reason for that is this. In a default constructor, we know a default constructor is a constructor which has no arguments, nothing in its parameter list. But since we're providing default arguments for everything in the parameter list, a person can do this. They can say sale, item sale, and not pass it anything, in which case it's treated as a default constructor. Now this can come back to be an issue later on, which we'll talk about when we get to it. Oh, are they not going to bring it up? Where are we at? I think they bring it up later on, but I'll go ahead and just say it now. All right, so this is the problem. If I have everything, it's not really a problem, it's just something that you need to be aware of. If I have default arguments for everything, I can do this. Let's go ahead and let's go back over to our code. Okay, so I can do this. Okay, so down here, I'm not going to do any of this. Comment this out. Comment this out. And then now I don't need to pass it anything. So I can just say this is equal to a new rectangle. All right. So this case is going to use default arguments for everything, 0 times 0. So let's run it, and it should print out, it shouldn't even ask me for anything, it should just print out 0, because that's the area, right? The area of the box is 0. Okay. Now let's say that I wanted a different default constructor, where I say, okay, this is what I want to do when the user doesn't pass in anything. RECT, and then RECT, and then empty, and this is what I want to do when the user doesn't pass in anything. Well, notice I get a red squiggly line. I can't do this. I can't do this because it's possible for the user to not pass in anything, in which case it does this. But now I'm trying to say when the user doesn't pass in anything, I want them to do this, whatever that is, right? Do stuff. So the compiler won't allow this because it can't differentiate which function it should call. If the user doesn't provide any arguments to the declaration, or sorry, to the initialization, when they create the instance of the class, then it doesn't know, well, should I do this or do you want me to do this? So that's just something to keep in mind, is that you can't have all default arguments, but then also have a constructor, which is you're trying to treat like a default constructor and tell it what to do here. You can't do that, okay? All right, and I think they mentioned that later in the book, but it's okay. We'll just skip over it if we get to it. All right. Classes with no default constructor. And this is saying what I already said. When you do provide a constructor where you require arguments, the compiler will not let you declare an instance which does not have all the required arguments in the list if you don't provide a default constructor. So like we saw earlier, if I do this, it's like now I'm basically saying when you create an instance of the class, when you create an instance of this class, you have to provide those values. Otherwise, it's a compiler, like we see here. Let's get the red squiggly lines. We have to provide something in here. Okay, I'm just going to put stuff in there to get rid of the compiler. So, all right. Moving along, destructors. So a destructor is something that is called when the object is deallocated. So when you call that delete function to delete the dynamically allocated pointer, it will also call the destructor for the class. To define the destructor for the class, all you got to do is put a tilde and then put the name of the class. So in this simple example, it's just going to print out when it's in the constructor and when it's in the destructor. So let's just do it ourselves. So let's go back over here, and then let's go ahead and create a destructor. And it's worth noting that destructors do not return a value, nor are they passed a value. So put the tilde. All right, so destructors will always look like this. They'll always just be the name of the class with a tilde, and you never, never, never pass it anything, and it doesn't return anything. let's go ahead and just see a simple destructor going in action. Let's go ahead and say RECT, tilde. All right, and this is just going to say, I'm not here anymore. Okay. All right. So just so we can see that in action, let's go ahead and here. So that's going to trigger the destructor when this line of code executes right here. So let's go ahead and see it. Enter the length, enter the width. The area of the box is 18. That should be I'm not here anymore. All right, so that's an example of a destructor. Now, if it's not dynamically allocated, this will be called when the function terminates. I'm sorry, when the program terminates. So let's go down here and let's make this not be a pointer. Oh, there it is right there. Okay, so we're going to have to put this back up here. So we're just going to make this a regular non-pointer version. Box dot set length. Let's set the width. This is a long lecture, I know you guys, but classes unfortunately are a fairly lengthy topic. Okay. Okay, and then finally use the dot operator there. Okay, there we go. Why are you unhappy? Oh, because it doesn't have a default constructor. So we'll declare it here. Oh, and we don't need to call set because we're did all that for nothing. Okay, so we call box, and then we pass it the length and the width. Okay. All right, so notice that's a little different too with pointers, right? With pointers, you use new, and then you put the arguments in there. And then if it's not a pointer, you just put the parentheses right after the name of the instance of the class, and then that's how it's going to initialize it. All right, so again, we're trying to see it call the destructor. Notice that we're not calling delete, but yet it will still call the destructor. It'll actually call it when it hits return 0. That's when the destructor will be called. So the length is 5 by 2, the area is 10, and it didn't call the destructor. Could be that that happened because it happens, or the timing of when it happens. In any case, and in the interest of time, I'm not going to go ahead and dive through why it's not printing it out, but it is calling the destructor, I guarantee you, even though it didn't print out that message. Okay, let's go back over here. Okay, so here's some examples of the destructor running. Okay, for this example right here, I'm going to encourage you to skip it. It's talking about character arrays, and character arrays aren't used anymore. We use strings now for everything, so don't worry about this example. All right. Okay, this is still part of that example. Okay, and then I think we're pretty much done. So, well, almost done. So here it's telling you what I already told you, that the destructor will not be called until you call delete. That's all it's telling you there. And then overloading constructors. We can overload constructors just like we can overload functions. So remember, function overloading is when two functions have the same name but different parameter lists. So why is that useful? It's useful because we can do things like this. So we can have a default constructor where we don't pass it anything, but then we can overload by giving it something like this. So now we're going to say we can also create an object and just pass it a string that is describing that object. So what is this object? It's a inventory item. And an inventory item has a description, a cost, and the number of units that are on hand. So we can create an instance that doesn't have anything, in which case we just initialize everything to blank. We can have an overloaded version which just takes a string, which will just initialize the description and then sets everything else to 0. Or we can have a third version where we make the user provide everything. Well, we don't make the user, the person provides everything, in which case it initializes everything using those values. Description C and U, description C and U get assigned to those private member functions. Okay, so that's what we can do with overloading constructors. And then down here, they're going to just give you an example where item 1 uses the default constructor and then manually sets everything. Version 2 uses just the description or the string and then sets the cost and the units to 0. And then in this third example of creating this object, we're giving it everything, right? And then just make sure, you got to make sure everything has a unique name, item 1, item 2, item 3. Okay, so I again encourage you to look through that. Okay, only one default constructor and one destructor. And then this is telling you what I told you earlier, and I thought they told you later. This is where they tell it to you later. If a constructor has all default arguments, it's considered the default constructor. So you can't have both. You can't have a constructor that has nothing in the parameter list and another one that has all default arguments. And then finally, they just show you here's another example of overloading. In this case, you can just as you can overload constructors and functions, you can also overload member functions. So you can have a member function called setCost, which you pass doubles, or you can have another version where it's passed a string, and then it manages to set the data correctly. Don't worry about what this is actually doing. It's just know that if the user provides a double here, like 5.2, it'll do this. If they put it in as a string using double quotes, actually this is a string class, so they can have a string format of it. You can just have multiple functions that can properly initialize it based on the type of the data that is being used to pass to it. All right, you guys, I know that's a really long argument, and unfortunately I still need to go over the lab, so this is going to be the longest lecture of the semester so far. I appreciate you guys hanging in there, but all right, let's see. Let's go back to the lab. All right, so for the lab, you are going to create a program that does the following. It is going to you're going to create a new class called contact to store a person's first name, last name, email, and phone. All of these are going to be stored as strings. You are going to write member functions called get first, get last, get email, and get phone. So all of those are just going to return what these values are. And then we're going to make it so that the constructor, I know this is kind of hard to read, but we're going to make it hard so that the constructor requires all the data above be provided when you create the instance of a contact object. So let's go ahead and see how we can do that. Let me give some code to help you. All right, so I've already given you guys, shown you how the online version you can break up your code. So you're going to want to make sure that you have 3 files for this lab: main, contact.h, and contact.cpp. So I'm not going to use the online compiler because it's not as fancy as the compiler I have at home. All right, so let's go ahead and start off with that. So how do I include those? I'm going to go to my folder here and say add a .h file for the header and name that contact. That'll give me a new blank file here. In this program, I don't have anything so far in my main, and then we also need to include the .cpp file. So let's go ahead and include the cpp file, and remember you want to name that the same thing as the class. So contact.h, contact.cpp. Okay, next, I'm going to go ahead and use the keyword class, and then this is going to be called contact, and then my semicolon, and then my private data, and my public data. All right, so there's the shell for it. Remember to use include guard so it doesn't get included accidentally more than once. So if not defined, and all capital letters, contact underscore h, then we immediately define it. Underscore h. All right, so there's my include guard, and then down here I need to say end if. All right. Okay, next, why am I getting a squiggly line here? I think that'll work, but it's just, I think It's not a problem. All right, so next in your private data, that's where you're going to include the stuff that it tells you here. You got to have a string for the first name, the last name, the email, and the phone. All right, so we're going to have to also include string class. Okay, include string. Okay. Down here, I'm going to have my string for the first name. And I'm not going to do everything because this has already gone really long. Okay. Next, I'm going to go ahead and put my member function. So the first thing I want to put is my constructor. Okay, and this is going to get passed a string for the first name. I'm going to put fn for first name. And then I'm going to go ahead and cheat. I don't want you guys to cheat, but, well, I guess I won't cheat. I was going to do it inline, but I want you guys to use multiple files, so I won't do that. I'll just go here. Semicolon. Okay, so next I need to start providing my function definitions in my CPP file. And before I can do that, I need to include with double quotes. Oh, it did it for me automatically, contact.h. Now I can provide my definitions. Okay, first name, and you guys cannot read that probably. All right, okay. Now because I'm using the string class here, I need to include that class here as well. Now actually, because I'm including it here, I think it should be okay. Okay. Okay, why is it not finding contact? CON contact. Make that bigger. Contact. No, it's there. It'll find it once I compile probably. Okay, so then now in this I'm going to initialize first in my constructor. So first is equal to fn for first name. All right, and then in main, I'm going to include the header file for contact. And let's try to make an instance of a, let's just go ahead and try to compile this and make sure this works. Oh, there was build errors. Okay, let's see. Contact.h. Surprised it's not able to find that. Okay, this is telling me that it can't find the contact class, and in the header I'm realizing I need to include the string class so that I can use it here, but I forgot to put using namespace std, so let's put that in there, using namespace std. Okay, now let's go back over to here, and you can see that gets rid of the problem. All right, I also don't need using namespace std here, and I don't need to include string here because it's already been included in the .h file. All right, so remember, it's just going to do a big copy and paste. It's going to copy all this code right here over the top of this line of code right here. So I don't need to include string more than once. Okay, so let's go ahead and go back to our main, and let's declare, let's go and just try to compile that. Let's see if we got rid of that bug. Ta-da, we got rid of our bug. Okay, so now that's how you guys can start off your class, okay? So there's your class, and then I'm not going to do it, but so right after this, you're going to have to also put a string for the last name, and then a string for the phone number, and a string for the email for the person. Okay, so let's go over here, and let's just well, actually, let's see. Let's go back over here. Okay, so that's how you can do the first part of declaring the class and a constructor that requires all four things. So mine only required the first name, but you guys should also have string, 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 string. One for the first name, last name, phone, email, and then over here, same thing. You're gonna have string for the first name, string for the last name, so on and so forth, and then you're gonna initialize everything instead of just the first name. So hopefully you guys can figure out, based on what I've shown you, how to do that. Okay, member functions are going to be get first, get last, get email, and get phone. So all those simply do is return the appropriate string. So what would that look like? So in your .h file, we're going to have a function called get first name. And it doesn't get past anything, and since it doesn't modify anything, it's a constant function. And then next, we're going to create the definition for that. All right. And then remember, you got to put the name of the class that it is tied to. Like that. Okay. Oh, and it returns a string. Okay. And then this one, I got to tell it the same thing. I didn't put the return type. There we go. Returns a string. And so over here, all we do is say return whatever you named the first name variable over here first. All right. Wow, this is a long video. So just so we can see this in action, let's go ahead and declare an instance of a contact. I'm just going to call it C. And then we have to provide the name. So let's go ahead and get a name from somewhere. I need to store that somewhere. I keep forgetting to put semicolons. So we'll make a temporary holder. I'm just going to call this temp and pass it whatever the person puts. And then just so we can see the function actually, the member function actually working, let's go ahead and print out whatever the person puts. Cout temp dot get first. Is that what I called it? What did I call it? Can't remember what I called it. Get first, yeah. Why is it not recognizing that? Get first. Okay. Is it not defined yet? No, I defined it. Get first. Let's figure out why this isn't happy. Oh, because this is not the name of the class. I just called the class C. So it should be C.getFirst, not temp. So temp is just a string. All right, so we ask them to enter a name, make a temporary string variable to hold it, and then we create a new instance of the contact class called C, and we pass it in the constructor the name that the user provided. Okay, so let's run that. So all this should do is collect a name from me and then print the name right back out by using the member function. Oh, it didn't do anything. Oh, because I forgot to do a cin statement. All right, so enter the first name and then cin temp. There we go. All right, so enter the first name, John, and then there it prints it back out. Okay. Sorry, this is taking so long. All right, each member function should be passed nothing to return nothing, and return the appropriate string, and make sure that the functions are const. Okay, so let's do that. All right, the next part's a little tricky. Now, it's worth noting that I'm not demonstrating one thing, which is this. This is a do-while loop, which has inside of it an if-else-if structure, where if the choice is equal to 1, you do this. If the choice is equal to 2, you do this. Now, in the past, we put those into functions, but just for the sake of simplicity, you guys can go ahead and just put the code that executes what should be done for each of these options right there in the program, okay? All right, so that's what would be here in main. It'd be do, and print out the menu, ask for the menu choice, and then if its choice is equal to 1, then you are doing the first thing, which is to enter a new contact, in which case you would do the code you just saw here. get the first name, the last name, so on and so forth, and then create an instance of that using those values. However, there is one other big thing that I want you to do different in this, which is we are going to store all of the contact information that the user provides into a vector, and we want that vector to be a vector of pointers to a contact object. All right, and that's how we're going to store everything, and we're going to use the push back method of the vector to store a new instance in that vector. All right, so how do we do that? So first off, you need to make sure you include vector. And then at some point outside of your do while loop, you're going to have your vector declared. So this is going to be a vector of pointers to contacts. All right. And then we'll just make this, we'll just call it address. I'm spelling things wrong. Address. No, I'm spelling it right. Address. Am I spelling? Oh, it's 2 D's. Sorry, you guys. Address book. Okay. And right now it's just going to be, why does it not like pointers to contacts? Expected a type specifier. Yep. Contact is the type specifier. Yeah, right then. I'm sorry, I put the pointer in the wrong place. Just like you'd put int star, double star. So this is a vector of pointers to contact objects. So, and it's right now it's currently empty because the vector doesn't have any default arguments that have been passed to it. Okay, so this is like what you would do. So again, this would be outside of your do while loop. So in your do while loop, if the person chooses 1, get all the information that you need to initialize that object. And then now, because it's a pointer, a vector of pointers to contacts, instead of making this a instance, we're going to make this a pointer to something. And we're going to have to initialize it by saying that it is equal to a new instance. And then here's where you pass in all the information: first name, last name, phone number, and boy, I'm just getting compile errors all over this. Where you pass in all that information. Oh yeah, it doesn't go with new, it goes with the constructor, which is called contact. There we go. So that's what you do to do that. And then of course we need to use the arrow operator if it's a pointer instead. Okay, now this you would not do. That's just showing that it's working. So again, this is for if choice is equal to 1. This is the code that you would use. So again, this sits outside the do while loop. Choice is 1, collect all the information, and then pass all that information here in the argument list to the constructor contact. Okay. All right, and then once we do that, we need to store it in the vector. So we're going to use the pushback method of the vector. So we'll say vector dot vector, not vector, address book dot pushback, and pass it the new pointer to the contact that you just made. Okay, so this is the code that you'll execute every single time for choice 1. Note that because we're using new, the other thing you need to do is before you are done with your code, you need to delete everything that is in the vector because it was all allocated using new. So outside of the do while loop, after the person chooses to exit the program, you'll also need to use a for loop to delete everything in the vector. Well, I is less than, I'm just going to copy this name because I'm lazy. Dot size I plus plus, and then you're just going to delete everything in the address book. So address book I is going to need to be deleted. Okay, so that little for loop right there will go through and delete everything after you get done, after the user chooses 3 to exit. All right, let's see. Let's see what else do we need to do here. Okay, so that's for all the code that you're using for choice 1. For the search for contact choice is going to do the following thing. So if they choose to search for contact, the program's going to ask them to enter the last name of the person that you're looking for. In this case, the user is looking for somebody by the last name of Smith. Now, it should, if the name is not there, the only thing that's been added to the contact vector so far is a person, John Doe, so on and so forth. And so there is no person with the last name Smith, so your program should correctly print out the requested name is not in the contact list. Otherwise, if the person is there, so this time they're going to look for the word Joe, John Doe is in there. If it is in there, it's going to stop and it's going to ask which contact information would you like, the person's email or the phone, and then it will say that the person chose 1 for email. So the program prints the email for John Doe is jdoe@yahoo.com. And then 3 just says thanks for using the program. Okay, so very quickly, how would we do choice number 2? Okay, for choice number 2, we're going to use another for loop to search through the vector. So obviously, we're going to have something similar to this, but we're probably going to have a lot more code for choice number 2. All right, so first, before we look through the address book, you're going to have to ask them what name they're looking for. I'm not going to code that, so get the last name they are looking for. Okay. We're also going to declare a variable out here that's a Boolean to see if they find the name or not. So in here, we're going to just go through every single thing in the vector looking for the last name that the person entered up here. So we're just going to say if, and then that'll be stored in some variable like name or something like that. So we're just going to put something like if name is equal to address book, address book I. So it's going to go one by one, and again, name is an error because I didn't see out cin up here. But so assume that that's a variable, a string variable that I declared up here. So if the name is equal to the ith address book name, so you're going to have to call the get name function. Get the person's name. So in this case, I'm using first because that's what was up there. Okay. Let me go ahead and just do this cin up here so you guys can see it work. Name. And then I'm just going to initialize that to something. So this is, again, this should be a cout cin, but okay. All right. Oh, it's a first name. All right. So we're saying the person is looking for the name Tom. So if Tom is equal to address book I get first, that's going to return the name first. Then we want to do something. What do we want to do? We want to ask them if they want to print out the email or the phone. Okay, so you're going to put that here. So do they want to print number 1 for email or number 2 for phone? And then if they put 1, then call the get phone number. If they push 2, I'm sorry, email. So if they choose 1, you're going to have the get 1 is email. So you're going to call get email if they choose 1. Otherwise, you're going to return the phone number. And then you're going to put a little fancy format here and say the email for, and then you're going to use the get name function, get first, get last to print those out, and then is, and then here's where you use the get email function call. So that's all going to go inside here. The other thing that's going to happen here is you're going to set found to true so that you know that the name was in there. All right. So this is if we found it. Now I also made a caveat that you can assume that each contact is entered into the vector. Oh wait, where did I say it? Yeah, there we go. You can assume that each contact has a unique last name. So there's not 2 people with the last name Smith. So you don't have to have extra logic in here if this happens more than once. And in fact, if it is the case that you're in here, you find it, print out their phone number or whatever, you can actually just do a break statement at this point. And because there's no point in looking through the rest of the address book once you find the name that the person is looking for. Okay, and then finally, let's see, so that's if that. Finally down here, we have one more if statement where we say if found is equal to false. Then we're going to print out that extra message where we say the name was not found in the book. Okay, so this is pretty much most of the code that you would need for executing option number 2 in the menu system. All right, this was a really long video, guys. If you stuck all the way through this, hopefully this code is going to help you out with this lab. This is by far the most complicated lab that we've had to do so far. It uses classes, vectors, and pointers. If you have any problems or need any help on anything, as usual, just let me know. One last thing is, how are you going to turn this program in? You're going to need to turn in all 3 files for this to get full credit. So how are you going to do that? Well, if you're using your own compiler, you're going to have to find these files and zip them up into a folder for me. Or if you're, I shut the online compiler. Let me open that back up. Okay, last thing, I promise. So if you're using the online compiler, you're going to have to download all 3 of your files. Now I know this is a rectangle example, but this will be the contact code for you. Just click on download code and download all 3 of those things to your desktop. You'll probably want to create a folder called something like lesson 16. I'm going to go ahead and delete that one. Let's just make okay, cancel. Okay, why is it not letting me do that? Because the compiler's open? Okay, let's close that. All right, let's try that again. Okay, so rectangle.h, download code, desktop, will let me delete it now. Yes, okay, so you're going to make a new folder, call it lesson 16 underscore 16. Because for this submission, you're going to submit a zip file, not just a main.cpp. All right, so I'm going to download rectangle.h. I know you can barely see that, but I'm going to download rectangle.h. I'm going to download rectangle.cpp into that folder. Same thing, lesson 16. And then finally, I'm going to download main into that folder too. Let's go to the desktop and look into our lesson 16 folder. So there's all 3 files, main.cpp, rectangle.cpp, rectangle.h. And then we're going to right click on that and choose send to compressed zipped folder. And this, my friends, is what we're after. That's the final thing that you'll submit. So in the assignment submission, you'll see that it's restricting it to just zip files. Just make sure that you got all 3 files in there when you go to submit it. All right, and that's how you're going to do the lab for today. All right, that was a long video, you guys. Good luck with this, and I will talk to you again soon.